Okay, hello. So I'm now reporting my progress in transforms. So first, how I define 3D object position in different coordinate frames. In here I have coordinates, two coordinate system where I have changed the positions of those unit vectors. So that how first I have this point over here, which I can represent like that, and that point is in way 3, 2, and then there is at that point, but if we replace take this out, we find out that we have to find that same point from in that point. So that is x and y, and how we define that, it becomes by this this is not needed if it isn't 3D, and then we defined x and y in that system, and we make a minus, and then we find that vector how we solve x, I'm sorry, just plus, because we first find out because it's that vector, and then we find out this vector, and that count we found it. Okay, then we have how to create transform matrices. Those transform matrices, it could be found, I have this kind of representation over here where I can show you how it be done. So over here, when there is a coordinate system, let's take those off. We have coordinate system like that, where we're presenting that coordinates by this line, where this represent that y-axis, and this vector we representing the x-axis. And that's how we defined those vectors, and this is how created defined. Let's find out. There is a point. Sorry. So we can have our when there is a matrix position x, this x could be changed to t times x, and with this solving system we find out that inner vector invert matrix C times A times C creates a solution to that, find out that transform matrix. Okay, then next one, how orthographic and perspective projection differ. About those create transform matrices, this is also a second way to there is a 3D geometrical transformations which representing like 4x4 matrix, and by using here those transformations, let's see, if we want translation, we change those these elements of that matrix, and then by cross product we found out a new vector for that. Then we can translation it. By scaling, we change these three matrix elements, and then we can find out the scale of that 3D object, and the reflection becomes by changing the scaling inverse. And then there is also 3D Gaussian, but the most useful thing is a rotation, where we can rotate that rotate the axles. So by y-axle is a cosine theta, because it's y, you see that this this row over here is unchangeable, and we change only x row and z row over here, and we change those by cosine and sines, and by the z-axle we don't change the z row, we only change the x and y rows over here by cosine and sines, cosine and sin and minus sin and sin. That is change that kind of changings. Okay. Well, then the orthographic and perspective projection differ. I have this kind of wonderful paint over here, where this perspective object is defined so that is a cone, not like cone, maybe cone, but it has been limited to this, because this perspective just continue and continue forever if it's not limited to end up. But the main differ is that how he presents the world, what he sees. For example, I have two spheres over here, and this camera, or is it a person, whatever camera right now, it seems that this sphere and this sphere are the same size when it's perspective, but in orthographic this C view viewport is all a cubic, and it's not changeable at all. So that's why that little spare is still a little spare over there, and this big spare is still a big spare when it has been printed over here, and over here it's printed like this, and that's why the same size. Okay, let's go to the next one. Transforming order works. I have used this scene graphic builder for representing all the variables of those transformations. Over here is first transforming, then translate. It changes first those the direction. Position is better, yeah, and then scaled, and then rotate, and then it's that square over there, and then that square, it is the same location, and as we see that matrix has not changed a bit when rotate and scale change. But when we change that first scale and then rotate and then transform, we see that that square is in different place because the order of those matrices has changed. Okay, and the changes differs how these matrices are ordered. Okay, then the next one, how scene graph and transformation graph works. As we see that this could be, if we unlink these things and we make a new way to link those things. I'll link. It is more better expressed over here. As a human, we have body, and then we have chest, stomach, and pelvis. And over there we have a right shoulder, which chains with his chest are connected to right shoulder, and right shoulder chains the elbow, wrist, and hand. And when elbow is moved, then the wrist, hand, and everything, fingers are below, changing the position. But when we change only wrist, then the hand and the fingers are changed. And when we change hand, the fingers are changed, but not wrist. And then if we change thumb, then the thumbnail is changing the position. And the same thing with neck. When we have neck, we change the position of head, and in head we have eyes. And as the left shoulder, we have the same things. And same thing happened with our ankles and feet, and we have groins, and then we have a left hip, and that's how we are. If we change something, example, this angle, its rotation, position, or maybe scale it, then the all things scales below in that element, then